2018. But we're still talking 80–82% waste, so a huge way to go. So that gives you some kind of handle on the context.
Thanks, Morning. Skip, you mentioned multiple times this idea that you need to move focus away from the supply side and put it on the demand side. Am I interpreting this right? Are you seeing this as zero sum? That there's, in order to focus on demand, you've got to take attention away? Or where do you see that critical resource that has to be utilized?
I'm not sure I quite understand your question.
You've said a few times we need to move the focus away from the supply and power and lower the price of power and move it to efficiency.
Right.
Do you see this as zero sum where there can be more attention put on efficiency without removing some from supply?
I don't see it as a zero sum. I see it as rather a different dynamic altogether. For example, and maybe to give you this idea, 1 joule, which is an international unit of energy, if you imagine an apple, about 100 grams, a medium-sized apple, lifted 1 meter off the ground, that requires 1 joule of effort. And it actually requires that joule to perform that task, to move against gravity, overcome friction, what have you. If I wanted to lift 2 apples, I absolutely need that 2nd joule. It does require the energy. There has to be energy supply, 1 joule per apple, 1 meter each. But I'm not a particularly efficient machine. It might require me as a machine like 20 joules. I may be out of shape. You may be fighting me over that apple and constraining, pulling my arm down. I've got to put energy into my brain and my liver and my heart to keep me alive. All those different things. I do need the 2nd joule. I do need that supply. But if I brought about a lever, or you and I quit squabbling and we reduced our war against each other for that 1 apple, we now have 2 apples, we're reducing the total amount of energy necessary to achieve the 2 joules of effort. So we can imagine lifting 2 apples, doubling our output, if you will, but maybe only using 30 joules instead of 40 joules. If we step back and look at what's really holding us in abeyance to keep from doing the job that we want to do. So it's in that spirit, I'm saying that if we focus on the task at hand and what are the minimum requirements necessary to put that into work, put that into action, we may not need the 40 joules, we may need only the 20 or the 25 or 30 joules to actually double the output. But that requires a refocusing of how we see the problem.
So it needs to be refocused on supply, it can't be focused on both. And that's something I'm having a hard time kind of coming to grips with.
Yeah, and I'm having a hard time understanding your question.
You're saying
what I would say is
we can't focus on supply and efficiency at the same time.
we can. So for example, I still need the 2 joules. And as my current state of the art is, I may need 30 joules of total effort to get the 2 joules worth of work.
I didn't understand.
Okay, so we need to bring both at some point. And so in the case of the region of France, I mentioned Pas-de-Calais, they want to bring their total energy use down by half by 2050, but they want to meet the entire balance of that with renewables. So they're focusing on both the supply and the efficiency side, but they realize they would not be able to do the job unless they approached it from a much more productive use of resources in the first place. Both have to come together. Does that do a better job?
I think so. We can talk after.
Okay.
Yes, sir.
John Joseph, the Energy Future Coalition. Skip and I go back a pretty long ways. And Skip, one of the results from your studies that I had always cited on the Hill and elsewhere was the fact that our energy efficiency actually created about half the energy we thought we would need between 1970 and 2010. We ended up using about half the national energy that we were projected to use from that period, and yet your slide shows that during that same period we actually didn't achieve very much more efficiency. So I guess we were projecting that we were going to actually worsen our efficiency by half, given our original energy consumption projections. Is that the right way to look at that?
Yeah, 2 different things going on. The slide and the talk I gave a couple of years ago was saying that for the U.S. economy to move ahead at the pace it has since 1970, In fact, a number of my colleagues still at work today forecasting the future would say the U.S. needed about 200 quads of energy by the year 2000. And we hit 100. And the reason for that is because I think there's a better understanding of energy. The market proved to be more dynamic, and we actually did implement a number of key policy legislative bills and the like. I mentioned National Energy Act in 78, Energy Policy Act 92, and so on. Those had a positive impact, absolutely, in bringing down and a more dynamic market with much more innovation than we would have imagined, say, in 1975. But that said, I'm now switching gears and I'm digging deeper and saying, tracking energy as a commodity is different than tracking energy as a form of work. And once you begin looking at the minimum amount of work necessary, so for example, like incandescent lamp may have 8 to 10 lumens per watt, but the maximum is probably 200, 220. So we're talking just a couple percent efficiency at best. An LED may give us today's technology up to 40, maybe 100 lumens per watt, much greater improved, and with some of the technology on the horizon, we can move up to 160 lumens per watt, very close to the maximum of 200 or 220, depending on what your reference point is. Looking at it that way, we've seen that we actually have not been performing as well measuring actual exergy that becomes work, that drives labor activity, that animates and enables capital to do its thing. So it's two different forms of measurement. What I'm suggesting is if you want to get a handle on the way the economy works from a pure physics standpoint or physical standpoint, yes, economics is important, yes, prices matter, yes, policies matter, but to understand the fundamentals, to redirect prices, to redirect policies, to accomplish a different task than what we imagined. And it's that kind of a spirit I'm trying to suggest. We've made huge progress, but moving from an Exergy efficiency of 8% in 1950, only 14% all these years later, is not a very big accomplishment. And I'm suggesting that's among the things holding us back in terms of the waning, the vitality of the U.S. economy. But it's not us alone. I see it in OECD numbers, I see it in developing countries as well.
Zach Lindley from Indiana University. It's a very interesting story about energy efficiency leading to job creation. I'm wondering what kind of empirical evidence you have to bolster that view, or whether you're also concerned about whether or not energy efficiency improvements can lead to capital labor substitutions.
Well, that's two different questions, and the answer is yes and yes. There are data to support the job creation capacity, and I'll give you two numbers just to start with. I mean, it's more complicated, but for purposes here. It turns out that directly and indirectly, every $1 million spent on an average basket of goods would be supporting about 17 jobs in the U.S. Directly and indirectly, every $1 million spent on energy in the U.S. supports about 9 to 10 jobs. So first set of numbers, I'd say, to the extent we can cost effectively move expenditures away from energy through efficiency gains, we're allowing the economy to redeploy, reinvest, move expenditures to a more labor-intensive area than we might imagine. Then secondly, as we do that, one might argue that we're then lowering the volatility of energy prices, we're dampening the demand, we're freeing up more of the resources to be used a little bit more smartly, more flexibly. That's bringing the cost of energy services down, not only for the efficiency part, but for those who don't immediately have the opportunity to deploy more efficiency gains. So the prices come down, and Jeff mentioned some of these things, like we're also reducing our risk to disruption of supply or to international concerns. All of those have job implications. The data are there. I've done about 120 of these studies over my career. And they are based on the very simple idea that as you move to your second question, the smart substitution of capital for energy, then we're beginning to see the opportunity to put more and more people to work as we then create the investment in the new infrastructure, and as we then begin to benefit from the energy savings that are spent elsewhere, and as they in turn moderate the volatility or even the slow increase of energy prices. So all those have an effect at work.
So I guess I would be more concerned if I were working in mining or the AFL-CIO,
about the distribution of the new jobs, or the capital base.
The distribution in two ways, you mean geographically and or in the
Among the
occupational
sectors.
category?
Do you mean class one, like the quality, job quality?
Yeah, among the sectors. So you're substituting away from industry toward the service sectors, or away from mining and toward services.
There's certainly some evidence for that, particularly around the residential energy efficiency. In the way that I framed it in the talk was that it's a global question, right? Because it's a displacing from countries abroad back to us by making us more competitive, more efficient, more productive. And that has all of its own ethical quandaries as well.
I might answer it a little bit differently, but in the same spirit. As a nation, we've not been very good at making winners out of losers. And yet, we know the powerful role of incentives. And as I've suggested with the one slide that I put up on the board, current energy costs are not doing a very good job of enabling the use of Exergy, useful work, to be smartly deployed. That suggests a need to step back and figure out a way to solve for multiple objectives. Usually as economists, we say, minimize costs. So we use LP-type models. Say, we got these sets of choices, we got these constraints, and we want to minimize the total system cost. There are now techniques to begin imagining how you can solve for multiple objectives and how to satisfy, to use Herb Simon's notion, maybe not absolutely minimal costs here, but jobs over here, environment here, and returns on investment over here. Can we begin to imagine ways of a recipe that solves for multiple objectives? And understanding that physical opportunity, then redirect policies so that, yes, jobs may be moving away from some manufacturing, but into other sectors that are also manufacturing or also high value-added services, or maybe technical engineering construction services. Allow a migration that has high-quality, dependable jobs as part of it, though. Sometimes we need to step back and imagine how that can be done in a physical way in order to match the right policies and prices to accomplish that.
You mentioned mining. So from a mining perspective, I don't really see that being a problem because so many of these other industries rely on equipment or electronics or something that needs minerals and metals. Short of tremendous new technologies that I can't conceive of, I think we're pretty good for the short term.
My name is Nick Boris. I'm here in Anchorage. My question is for Mr. Lager, and a comment first. ACEEE, I appreciate your work with them. I constantly look at ACEEE for new cutting-edge research, and I think you all do a lot in the energy efficiency community. So really want to work with them. They've got valuable conferences and really take a lot away. And today was no exception. I actually felt your presentation is inspiring in a way, the concept of energy versus Exergy. And I want to just clarify that Exergy, my understanding of Exergy is you kind of defined it in the 14% versus 86%. And my understanding that the traditional forms of energy efficiency is the low-hanging fruit, what we typically go to. And you're trying to point out that there's all these other forms of energy that we could be perhaps exploring further that may be more costly to get to, and the technology is not quite there, but that's the kind of stretch goal we should be moving towards, to explore these kind of non-traditional, non-low-hanging fruit opportunities for energy efficiency. There's a few more clarifying points about Exergy versus energy. Thank you.
Yes. Exergy is nothing more than the high-quality availability of energy. That is to say, we can, for our practical purposes, think of a gallon of gasoline as a form of Exergy. It's an ability to do work. That means the temperature, the pressure has to be above the ambient environment in order for work to be done. We can define Exergy in physical units like kilowatt hours or like tons of oil or steel or of coal, what have you. but a more complete accounting. It also includes the energy necessary to keep you and I alive and to work. That is to say, you may expend 1,500 calories of energy at work, and it may be only a very small amount, perhaps 2% of the total exergy at play as we add up. But the EIA doesn't count that. They don't count muscle power or brain power. And yet it is vital. Can you imagine? You and I would be inert lumps of matter without energy to animate and enable us to move ahead in the world. Tracking the real complete flows of energy that we really would call exergy is an important first step to better understanding the full economic process. So it's in that sense I'm talking about exergy. Now, energy, again, to go with the equation, energy equals exergy, the high quality stuff that we can do all kinds of things with in terms of creating and transforming matter into goods and services. The anergy is the heat that comes out of the exhaust of a car, for example. Energy and exergy and energy equal energy. Energy is always constant, but it gets degraded. And if we can imagine how exergy is brought forward to create momentum or movement or transformation at all levels, not just parts of the overall activity, but the full set of activity, animated capital, animated labor, as well as the energy flows, then we begin to imagine better recipes for accomplishing the tasks we want to see move ahead. We begin to imagine how to reduce that waste that allows us to amplify our ability to create that level of work that we desire.
Question for Mr. Pius. The mining industry using raw resources is basically competing more and more with recycled mineral resources. Certainly the steel industry is very much going to electric arc furnace using recycled steel and a lot of reclaimed copper. These facilities get a lot of copper stolen for that purpose. So you gave a good presentation of what the energy consumption is for the raw material mining in Alaska. How does that compare with the energy consumption of recycled minerals and materials from waste and regen?
The option of recycling these metals and you know.
I think you might talk.
Okay.
Actually,
What am I doing? Is that on?
Yes.
Thank you. Recycling is fundamentally important, and you know, kind of boggles my mind that every speck of gold that has ever been mined still exists in one form or another. But the demand is still right now outstripping supply, and that's predominantly because of development in the BRIC countries. China obviously leading the way. In the 1980s, China was responsible for, if I remember correctly, I think it's about 8% of base metal volume in the 1980s. Now China purchases about 30% of all of the base metal production, so you can see that growth. And elsewhere in the developing world, people are still building and still needing these raw materials. So recycling is part of that mix, but for now, the need for new minerals and metals out of the earth is still very, very strong. In terms of the actual numbers in comparing using recycled minerals versus raw materials, I don't have it, so I can't answer that. Thanks.
Any quantification, any attempts at quantifying the energy security implications of going from, say, Exergy efficiency of 14 to 20? So it's got to have, it would be needed, I would think.
Well, that's a damn good question, actually. No, I haven't thought about it that way, but that would be very useful to do. If we went from 14 to 20, I can imagine we'd cut our dependence on petroleum by a huge amount. And that's a good way to frame it. I will think about that. Thank you for that suggestion.
I think we're done for today. Thank you, everybody, for your participation.
Yeah.
I agree.
Maybe it's something more necessary, that's really not, and they're just looking for attention, so.
Yeah, it's not, because the pressure is yeah, like,
If we have one of the more efficient economies of making things.
well, use that, you know, it's.
Yeah.
Done that every single
At some point, infrastructure, we have new infrastructure, SPP replacing 30% more efficient, less fuel. Than everything.
Quarterbacks or something.
Yeah.
It had the most detail.
Well, no, it's on the energy is, it's just got wrong.
Just investing money in efficiency, reducing less, I think there is some validity there, but it's somewhere in the middle. It's not very.
Very, very.
Limitless focus. As far as capital and everything else goes like that, I mean, maybe there's some scarcity.
I think efficiency will always come out of it, you know.
Well, I think it hits both. There's not, it's just that we don't, there's no reason, they're not going to supply and efficiency are not as great. Well, the price of supply and the efficiency don't.
I like the shift in.
But I mean,
Yeah, I can see competing like fossil fuel versus clean. They're
So much generation.
but it's very.
Exacerbating.
Yeah, but